Good morning everybody. Welcome to this session of Transportation Engineering. Today we'll be seeing what is the importance of equilibrium super elevation. Basically in the previous class we had seen what is super elevation. As I had told you, whenever a traveler or a passenger, whenever he's riding a vehicle, there is a plain terrain also, but sometimes we come across horizontal curves also. At that time, when a commuter takes his vehicle forward, what happens at the horizontal curve is a centrifugal force is developed, which further we can just see it here. I'll just explain it to you here. So at this place, you can see the vehicle is moving at this way, but what happens here is the vehicle has to move like this. It has to take a turn here, but at this place what happens is, some centrifugal force is developed, and what happens at that place is this centrifugal force is has to be reduced here. A P force, centrifugal force is developed here. It has to be reduced. If that centrifugal force is not reduced, some measures are not taken to reduce that centrifugal force, or we don't come up with some idea where we can reduce this centrifugal force, there are high chances of this vehicle either it overturns or there are chances of skidding. So what is the concept of super elevation is, the pavement at this side, the outer edge is slightly, it is raised with respect to the inner edge, and raising of that outer edge is known as super elevation. Angle of super elevation has been given, and formula for super elevation has also been derived in the previous class. So we'll be seeing a concept called as equilibrium super elevation, where the friction, when the centrifugal force is developed at this place, even a frictional force takes place at this place also because of the tires. So we'll have to overcome that frictional force as well as centrifugal force. Then we get an super elevation equation. That is, we had got it as E plus F is equal to V square by GR. We had already calculated that E plus F is equal to V square by GR. In this, E is the super elevation, angle of super elevation, to what amount the outer edge should be raised. F is the frictional force that we got, and V is the velocity of the vehicle, G is the gravity, acceleration due to gravity, and R is the radius of curvature. Today we'll be seeing what is equilibrium elevation. What is equilibrium elevation? Basically this equilibrium elevation is that concept in which we don't consider the frictional force. We consider frictional force as zero. Here the frictional force will be taken as zero. Now depending on that, when we take the frictional force as zero, we will be seeing what will be the equilibrium elevation here. So we will be seeing about that. Let us see the figures what we will get here. Let us see the figures. Let us see how the forces will be acting here, and there we will be deriving an equation here. So as I had told you, equilibrium equation is basically equilibrium super elevation. Basically in this, the frictional force will be zero. We won't be considering frictional force. We will be just seeing here what are the forces acting. What are the forces acting here? We will be seeing that. You can see here, this is the angle that will be formed here. This is the vehicle that is moving. As I had told you, we will be getting centrifugal force as well as this is the W, this is the weight of the vehicle, and we have centrifugal force also, that is P. We had resolved this forces P and W with respect to X and Y coordinates. X and Y coordinates also we had resolved these forces. We have reaction forces also. We have reaction forces over here, that is RA at this tire and RB at this tire. Okay, the frictional force, normally in the previous class we had seen we also get a frictional force, but here frictional force we are neglecting it, and frictional force will be zero here. Please understand this concept here. We won't be taking frictional force here. Let the distance between these two tires be B. Okay, let the distance, and the distance from the center of the vehicle to the bottom here, let this be H. So distance from the center of the vehicle to the bottom of the pavement, from the surface of the pavement, let this be H. The distance between two tires, let this be B. Let us just see the forces that will be acting here. This force will be P cos theta, and one force will be acting downward. This is P sin theta. As you know, we had learned this in the mechanics subject, how to resolve the forces. We have when a force is acting, we'll have to resolve it into x-axis and y-axis. In those places, with respect to x-axis, the force will become P cos theta, and with respect to y-axis, the force will become P sin theta. Same way, we have a force here, W, that is the weight of the vehicle, which is acting downwards. We'll have to resolve this force also. Here, what will happen is this force will be W sin theta, and this force here, it will be acting in same way here only. So it will be W cos theta. See, we have resolved this. Please be, this is important here. We have resolved this force of W. This force is W, which is acting downwards. I have just resolved that force with respect to x-axis and y-axis. You don't get confused here why I have taken this as W sin theta. See, the concept in the mechanics of resultant of forces, it says if the angle it is making with the vertical, with the with the y-axis, then this x coordinate force will become W sin theta, and this y coordinate force will become W cos theta. If that resultant force is making an angle with the x-axis, then here it will be P cos theta, and with respect to y it will be P sin theta. So we have got all the forces here. RA and RB are the reaction forces which are coming up, which are acting at the tire, and B is the distance between these two forces. H is the distance from the center of the vehicle to the surface of the pavement, and W and P, as we have resolved it into different two forces, you have seen that. So we'll be seeing further what we'll get, as we are neglecting friction here. We'll be seeing what is the derivation, what we'll get. As I had told you, there are three equilibrium conditions we have: sigma x is equal to 0, sigma y is equal to equilibrium equations. We have three equilibrium equations. Sigma x is equal to 0, sigma y is equal to 0, and sigma m is equal to 0. Okay, we'll be seeing all these three equilibrium equations, and we'll see what are the equations we are getting after this. Hope this is clear till here. This figure is clear till here. Then we'll move. We'll see the specify. I'll just specify what are the different forces here: RA and RB, RA and RB. Reaction forces, let this be A tire and this be B tire. Please be clear here. Reaction forces acting on tire A and tire B. Okay, RA and RB are the reaction forces that are acting on tire A and tire B. Okay, then let us see, B is the distance between the two wheels. B is the distance between the two wheels, you can see here. And let us see H. Distance from surface of the pavement to the center of the vehicle. Okay, B is the distance between the tires, H is the distance from the surface of the pavement to the center of the vehicle, and P cos theta is the force with respect to x-axis, and P sin theta is the force with respect to y-axis. Okay, P cos theta, I have resolved that force, P centrifugal force, and P cos theta and P sin theta. And W is the weight of the vehicle. I am again resolving it into different forces. W sin theta is the force of the vehicle with respect to x-axis, and W cos theta is the force of the vehicle with respect to y-axis. And we get a normal reaction also. We know that normal reaction also, it acts exactly downwards, that is P sin theta plus W cos theta. See, the normal is exactly opposite. Normal acts here, that N is equal to P sin theta plus W cos theta. N is equal to P cos theta plus W sin theta. Okay, all the forces and whatever I have written, that is clearly specified here. Let us see the sigma x and sigma y and sigma m is equal to 0. What are the forces, different forces coming here? We'll just see that here. Let us take sigma x is equal to 0 and sigma y, and let us see what are the forces. Okay, equilibrium equations. We'll check all these equilibrium equations and then we'll equate them. Okay, you have just got this, all these forces here. We'll see the equilibrium equations now. Sigma y is equal to 0. We'll have to see what are the forces that is acting in the y direction. See, just be clear here. We have this force Ra is acting upwards and Rb is acting upwards. Let us take that. Ra is 1 and Rb is also there. These are the two reaction forces that are acting on the tire, two reaction forces. And then we have one more vertical force that is acting downwards, that is P sin theta plus W cos theta. This is the N normal reaction. So this will be P cos theta plus W sin theta. Let us take this equation as 1. Okay, please be clear. We are just checking what are the vertical forces that are going upwards. We are taking those forces at one side, that is Ra plus Rb, and those vertical forces that are acting downward, that is P sin theta plus W cos theta. I have taken that at the other side. Let us see now sigma x is equal to 0. What are the forces acting in x direction? You can just see here we have two forces here. P cos theta, one is the forces that is acting in x direction, that is in the positive direction. Okay, that is P cos theta. What is the other force that is acting? So that is, you can see here in the x axis, in the x direction, we have W sin theta, which is acting in the opposite direction. So I'll take it at the other side, W sin theta. Do we have any other force here? We don't have any other force. If in the previous problem we had considered friction, so we had one frictional force also here. But here, just because we are not taking frictional force, it is 0. We have only these two forces here. So this is the second equation. Let us see the third equation, equilibrium equation, that is sigma m is equal to 0. We'll be taking moment about tire B. We'll be seeing the moment about tire B. What is moment? Moment is force into the perpendicular distance here. So about tire B, we'll be seeing what are the different types of forces coming here. First, you have to recognize what are the forces coming here. Then we'll see the perpendicular distance here. You can just see here, we have one force of this P sin theta plus W cos theta. We have one force here that is acting downwards with respect to B. We have one force here, W sin theta, which is acting here. We have to see the perpendicular distance here. We have one more force here of P cos theta that is also acting here. We'll have to see what is the perpendicular distance here. We'll just specifically write these forces which are acting with respect to the tire B. Then we'll equate it and we'll get a solution here. Let us see that here. Sigma m is equal to 0. We have one force here, W sin theta. Let us see all the forces that are acting here. I'll just take this moment about the tire B. We'll see what are the different forces that are acting and what will be the perpendicular distance between those forces. Once we specifically write these forces, after equating that, we'll be getting some equation. We'll just substitute those values and we'll be seeing what is the equilibrium equation that is we are getting. Please be clear here. We have one force here, P cos theta. So this is the force P cos theta that is acting here with respect to B. So with respect to B, we are seeing this is the force P cos theta acting. But what is this distance? See, force into perpendicular distance. Force is acting here, perpendicular distance, this is Here acting, we have taken that distance from this to the surface, we are getting it as h. So P cos theta is acting in the right direction. So P cos theta, I am taking it as positive P cos theta into h. Okay, see, we have one force here P cos theta that is acting in this direction with respect to B, tire B, and the perpendicular distance, this is h, as I had told you, this is from the center of the vehicle to the surface of the pavement. So P cos theta into h. We have one more force here RA, which is acting in this way, RA. This is also in positive direction. You have to just check it like this. Put your thumb on the place where you are taking the moment and just place the finger here. So this is acting in clockwise direction. Clockwise direction, I am taking it as positive, and anti-clockwise, I will be taking it as negative. So RA into this distance perpendicular. RA is acting in this way. Perpendicular distance is B, plus RA into B, plus RA into B. Okay, these two forces are acting in clockwise direction. So I have written this. I have one more force here. So RB will be directly acting here, so it will be 0 here. We won't be considering this force. What are the other forces that are left? We have this force here, W sin theta. One more force we have left here. So W sin theta, just put this here, and if I take this, it is acting in the anti-clockwise direction. So I will be taking it that side. W sin theta into distance is again h is equal to W sin theta into the distance is h. So this is here, one more force is acting here downwards. This is also in the anti-clockwise direction, that is P sin theta plus W cos theta. But what is this distance? That is B by 2. As the distance between the two tires is B, this is acting at the center, so this is B by 2. P sin theta plus W cos theta plus P sin theta plus W cos theta into B by 2. B by 2, as it is acting from the center, the distance between the two tires is B, it is acting within the center, so this is B by 2. Let us just resolve this. We will see this P cos theta into h plus RA into B, okay, is equal to W sin theta into h plus PB sin theta by 2 plus WB cos theta by 2. Let us take this as equation 3 here. Equation 3, this can be taken. We have already have two equations, that is RA plus RB is equal to P cos theta plus W sin theta. P cos theta is equal to W sin theta. See, P cos theta is equal to W sin theta. That can be written here, P cos theta. From the equation 2, P cos theta, we can just substitute that as P cos theta is equal to W sin theta. Just see here, P cos theta is equal to W sin theta. I'll just write that here. If I get this as from equation 2, P cos theta is equal to W sin theta. I'm just substituting this P cos theta is equal to W sin theta in the equation 3. Let us see what we'll be getting here. P cos theta is equal to W sin theta, W sin theta into h plus RA into B is equal to W sin theta into h. Let this be same way only, P cos theta is equal to W sin theta. We can't substitute, this is P sin theta, this is W cos theta. Let this be here like this only, P sin theta by 2 plus WB cos theta by 2. So you can see here, this value and this value will get cancelled here. This value and this value is getting cancelled here. Now what is being left here is RA into B is equal to PB sin theta by 2 and PB cos theta by 2. You can substitute here, one more value can be cancelled here, RA plus RB. Let us just check that here. So let us see what is left here now. What is left here? RA into B is left. I'll just write this equation again as this only, I won't write it like this. Let us see what we'll get here. So it is P sin theta plus W cos theta into B by 2. Okay, it is clear till here. I have just substituted P cos theta is equal to W sin theta in this equation. After substituting, I have cancelled these two, W sin theta into h, I have cancelled both of this, and this is left here. Ra into B is equal to P sin theta plus W cos theta into B by 2. Let us see the equation 1 here. Equation 1 says P cos theta plus W sin theta, P cos theta plus W sin theta is equal to Ra plus Rb here. Ra plus Rb is equal to P sin theta plus W cos theta. We'll just substitute this value. Ra plus Rb is equal to P sin theta plus W cos theta. We have P sin theta plus W cos theta. I'll just substitute that with Ra plus Rb. Okay, P sin theta plus W cos theta is equal to Ra plus Rb. Okay, this is from equation 2. I got that. I'll just substitute this value here. So it will be Ra into B is equal to Ra plus Rb into B by 2. Okay, hope this is clear. It is very simple. I've just substituted this equation 1. In this equation here, P sin theta plus W cos theta is equal to Ra plus Rb. I've just written that P sin theta plus W cos theta is Ra plus Rb. Okay, now everything, all these terms we have got it in Ra and Rb. We'll just simplify it here. We'll get the final equation. Hope everything is clear till here. We have just seen the equilibrium forces, that is sigma x is equal to 0, sigma y is equal to 0, and sigma m. We have taken the moments. After taking the moments, we have got this equation. So Ra into B is equal to Ra into B by 2 plus Rb into B by 2. Okay, I have just taken this B by 2 inside this brackets. I have got this. Let us now take the Ra terms one side. Ra into B minus of Ra into B by 2 is equal to Rb into B by 2. See, I have taken the Ra terms one side and Rb is at the other side. Let us simplify this here now. 2Ra minus Ra into B is equal to Rb into B by 2. Okay, after simplifying this, what will I get? This will be Ra into B by 2. So this will be positive. 2Ra minus Ra will be Ra into B by 2 is equal to Rb into B by 2. I'll just cancel these values, B by 2 and B by 2. So the final answer what I'll get is reaction Ra is equal to reaction Rb. When the frictional force is not considered and the frictional force is 0, then the final what will be the reactions will be Ra is equal to Rb. So please be clear here. What I have done, I have just substituted this value of P sin theta plus W cos theta is equal to Ra plus Rb in this equation. After substituting, I'm just seeing what is happening here. Ra into B is equal to Ra into B by 2. I have taken this B by 2 inside the bracket, that is Ra into B by 2 and Rb into B by 2. Now after that, I am taking all the A terms, Ra reaction A terms at the one side. I have taken that. This becomes minus when it crosses here. So I have just calculated that. After calculating, I have only left with Ra into B by 2 is equal to Rb into B by 2. B by 2 on both the sides I have just cancelled it and I have got the reaction as Ra into Rb. So finally what happens here, you must have understood, when there is no frictional force acting here, so the reaction force will be Ra will be equal to Rb. So the pressure, the reaction on the tire A will be equal to the reaction on the tire B. So that is, it is very important when there is no frictional, when there is no friction acting here, the pressure in both the tires will be same. Whereas when there is friction in the acting here, when there is a centrifugal force also acting, weight of the vehicle also acting, and because of that there is some friction also acting here, there the equation will change. That is E plus F is equal to V square by GR, which we had calculated in the previous session. Here please be clear here, whenever he gives there is no frictional force, please you should understand that there is no frictional force, F becomes 0 and he gives you super elevation, he gives you velocity of the vehicle, he gives you acceleration due to gravity, we know that, and he gives you radius. We can just calculate the whole, we can calculate the super elevation, if we can calculate the velocity of the vehicle, and everything can be calculated. when frictional force is not given. Even if he gives frictional force, if he says there is some frictional force acting there in that conditions we can come up, we can just put those values and we can directly calculate what is the super elevation. So this is very simple, I believe. Equilibrium super elevation we have seen, where the two tires will have the same reaction forces when there is no frictional force acting on it, where the frictional force is 0. So here we have just solved this problem here, equation here. In the next sessions we'll be seeing what are we'll be seeing a problem, and we will be seeing the different other concepts also that is coming up. Hope this is clear till here. I request all of you all to please go through these equations, and they are very important and they are very simple also. If you go through these equations, there are high chances of one problem being given on super elevation also. We'll be solving that problem also in the next session. Thank you for this session.